Good evening, participants. Welcome back to the session. Am I audible? Hello. Am I audible? Actually, there is just a power cut, so that's why we are facing some problem. So let us just wait for 2 minutes, 2 to 3 minutes, and then we will start. Meanwhile, a few of the participant they may join. I hope my screen is visible. Good evening, all. So okay, so actually due to the power cut, maybe the academy will be unable to host the session live on the YouTube. So let me just confirm it. Okay, so good evening all. Let us start with our today's session. That is, we are going to cover the deep learning means the application for cyber security. Here we will be discussing about concepts, techniques, and various challenges that uh, the researchers working in this domain might face. So let us start. Uh, so basically, as we are all aware about the attackers, okay, that have evolved uh, over the time, and the level of sophistication that we are facing nowadays. So in modern digital India, we all are aware about cyber attacks. Most of us might have also faced some or other kind of attacks in different ways. uh, Most of the time, we are unable to figure out whether we are under some attack or not. So there are such a level of sophisticated attacks that even we are unaware about those certain attacks. So this session is specifically related to the application of deep learning that we have gone through till today morning session. How we are going to basically implement those concepts and whatever things we have learned to the cybersecurity domain, and how it is useful and evolved over the time. So basically, when we talk about the cyber attacks and cyber security, so basically the recent statistics shows that if you just observe here that 80% means the malware attacks based on Android operating system has basically rose to 80% in India, and that too is basically published by the CERT. Okay, so basically Indian Computer Emergency Response Team. So and this report is very much recent. Basically, it is till Q1 2025. So the Android malware attacks have basically evolved very sharply. The other one is the healthcare IoT ransomware attacks, okay, that disrupted critical equipment in Europe, okay, and this report is again from the same current year. Then in America, we have this very critical issue of SIM swapping cases, okay, and the recently we have also basically seen
We are facing some technical issues. Please wait.
talk about this activity is going to be covered using this deep learning technologies and concepts that we have basically discussed here. Okay, so basically to cover this one, I have basically surveyed various recent articles, and this is what the figure and a statistic that we have. So let us continue with this. So as I have already talked about the cybersecurity threats. So as we are aware about the ever evolving the digital network or digitization of the world. So as the digitization comes with some overall advantage, definitely there are various concerns that need to be addressed. Among them, one is the safety aspects that need more focus nowadays. So day to day means whenever we go through the news, most of the time we see or hear some of the news related to this cyber attacks. Okay, and unknowingly we are also part of that some kind of cyber attacks. So we can think of the cyber attacks means how they are being designed, the level of sophistication they are having. So to deal with those sophistication and complexity of the basically the nature of attacks, definitely we are going to have some tools that may basically not only not only just cover the patterns, but also it must be adaptive and it may evolve over the time. So to begin with, just let's just see the statistics from the current year itself. So the first one is that Android banking malware attack. Okay, so that was basically those malwares mainly targeted this UPI apps. Okay, so this a statistic is provided by the CERT India. Okay, and another one is basically the healthcare IoT ransomware. So even you might have heard about the recent attack on AIMS Delhi. Okay, so the attackers have demanded some money. Okay, they had basically encrypted all the files and they demanded money in return of those files. Okay, so likewise we have USA is facing nowadays SIM swapping cases related to the crypto wallets. Okay, and you might have heard about the Mirai botnets. Okay, so there are millions of botnets nowadays active. Okay, some of them might be a good one, means they are not basically targeting you in adverse way, but for this statistic, you can just figure out how much the negative or we can say the adversary botnets are there. So this report typically from Microsoft for the current year only. Okay, so now, so as we are the end of the FDP, so I hope all of us have gone through this AI taxonomies. Okay, so we have gone through this taxonomies. Some way or other way, we have covered all the aspects in our FDP. So uh, you must be aware about the super set. Now, if we talk about the deep learning techniques that are used in cybersecurity that we are using in the cybersecurity. So mostly, whenever we talk about deep learning, few of the concepts quickly basically trigger in our mind, and those are basically the deep neural network. Okay, the multi-level perceptron, convolutional neural networks, the GAN that you have gone through, the reinforcement learning, along with the deep learning model, so deep reinforcement learning, then residual neural networks. Okay, among them, if we talk about the lower level, we have talked about the LSTM, the gated recurrent units. Okay, the recursive, the autoencoder we have talked about. So the recursive autoencoder, likewise, we have different variations. So most of them are basically covered here. So might be the belief network was not covered in the neural tensor. So anyway, so this is not limited to this set of models, but this particular domain covers most of the deep learning techniques. Okay, so basically, before moving ahead, all of us, if we talk about the cybersecurity techniques, just 5 years back, there were most of the papers that were based on the classical machine learning algorithms like decision tree, the random forest, uh, like SVM, KNN. So these were various machine learning algorithms that were very frequently used in all the cybersecurity analytical models. Okay? But the basic problem, the basic shortcoming of this model was, can anyone tell me what was the shortcomings of these classical machine learning algorithms? Why we now move to this techniques? Anyone? Comments? Okay. So where will I find it? This one?
This one.
Okay. Anyway, it will flash here.
Yeah,
The comments.
I'll let you know.
Okay. Okay. Thank you. So basically, so uh, we all know why we basically adapted this DL. The basic, there were many reasons, but the basic reason was the feature engineering. How we have worked with the classical machine learning or algorithms uh, versus how deep learning is dealing with the that feature extraction, feature handling. Okay, so this automation, the feature learning automation was the key role of this deep learning, along with the non-linear, we can say, decision boundary that it can basically learn. Okay, so there were many reason to adopt this DL, but this was the major reason: the automation of feature learning and the learning of sophisticated decision boundaries. Okay, based on the nature of the problem or the data domain. Okay, and along with that, we have very immense corpus of data nowadays due to the digitization of the system infrastructure. So there is no problem with the data. So definitely those ML models were mostly targeted to the application or the domain where there were very scarce amount of data. But now, even in security, we have sufficient volume of data. But definitely there are different shortcomings of that one, the limitation on that one that we will see. Okay, so basically, if we talk about in terms of security, so we were working on those classical machine learning, while now we have just shifted our focus to deep learning based technique, just because of the reasons that I have listed. Okay, now, so now many of you might have wondered, oh, how this CNN will help. Definitely, we can say that DNN will help, but how CNN will help? So whenever we are going to talk about the malwares that all of us are aware about, so whenever we are going to talk about malwares, So malware comes in binaries, okay? And if the sample itself is in binary, can you suggest why we should go with the CNN then, and why the CNN will be useful there? Suppose I have given a hint that the malware files comes in binaries. Okay. Now we need to use some model that will learn the feature along with the uh, complex decision boundaries. That is nonlinear or whatever we want to say. So can you suggest me? Can you tell me what is the reason behind opting for convolutional neural network, and when you should opt that one? Anyone? So basically, as you might have learned while discussing the LSTM, I also told you. So there was a concept of parameter sharing, and that in case of CNN, we had the concept of this kernels and the spatial parameter sharing. Okay, so basically the CNN, if we treat that binary as a say, the image, in say like for 6 or basically basically mathematics, uh, we can basically map in we be able to basically map. So we anyone can in which scenario you would like to go with the or you would like to opt the GANs or generative model? How many of you have heard about the zero-day attacks or vulnerabilities in cybersecurity domain? So basically, if you are aware about zero-day cyber attacks, so those are the attacks that are either unknown to the public domain or they have just reported. Okay, we don't have much information, or the information about the attack or what the vulnerability is still not means circulated among the cyber experts or in the public domain. Okay, so that is the zero-day attacks. Now, so in order to tackle the zero-day attack, the situation is like we have to catch a thief. To know how he or she look. So, he or she, please inform us so that we can correct it. Of this networks. Okay. So among that we have talked about the when we when to use the CNN, even in non-binary samples also we can apply the CNN, but the level of accuracy or robustness of the model depends on the underlying data itself. Okay, so we must be aware about what kind of data we are having in our hand, and which model will work better for this one. And for generative adversarial, your the attacks that I have just mentioned, the zero day attacks that comes under zero day attack. So basically, those attacks are either the samples for those corresponding to those attacks are in a very sparse amount, or they are in very so we may also use generative framework to basically mimic or to the So basically, many of you might be already working on this one, and actually working on the basically those data or the domain, the cybersecurity domain. Okay, so basically the cybersecurity challenges, the main area that can be covered are basically it is mostly the malware detection. Okay, then one popular solution is IDS, the intrusion detection system. Then we have phishing attack. That phishing attacks nowadays very common. Then a spam. We all are aware about the spam related to this email. It is same to that one. And then the personal damage of websites. So how we can basically cope up with those things. Okay. So before starting with the deep learning, definitely deep learning is a data hunger model. Okay. It is very much a data oriented model. The amount of data we accept also. So we need to look around the parameters. Okay, how many parameters we are going to learn. Okay. So what we maybe maybe it is basically the Windows oriented file that contains the structure that is helpful to execute some. Okay, so PE files, it contains some PE headers and other information. Okay, so metadata will be there. Then when we talk about the phishing spam, we may talk in terms of emails. Okay, and then for website defacement, the data may be sourced from website itself. Okay, now based on this data, either we may opt for static analysis or dynamic analysis. Okay, so based on that, we may opt for various tools that will help us through static and dynamic analysis. So I will also try to say that we are also going to host some basically the MTP on malware analysis in the month of August. You might also go through if you like. If you are working in that domain, you might be interested in going through that FTP also. So anyway, so if we are working on the static analysis, so static analysis basically gives us. So let us first define what a static analysis is and what dynamic analysis is. So whenever we are having a source code or the malware file, so there are two approaches. Either we are going to just study the file itself without running it. Okay, just go to the source code. Okay, so or the other way around is just try to have some virtualized system, and within that virtualized system we can basically run the code so that the behavior will be evident to us. Okay. Now, whenever we talk about a static analysis, so now that a static analysis, based on that static analysis, we may go, whenever we talk about a static analysis, there are reverse engineering tools that we may opt. Like suppose if the malware is in binary form, so definitely we will be unable to basically uh, read that file, what it is doing, what is the purpose of the file, and what are the files that it is going to infect or it is going to use. So those questions we cannot answer until we basically try to map it in some higher level language. Okay. So there are reverse engineering tools that we can use, and once we map it, we can extract the features from that basically reverse engineered file. So reverse engineering can be attained by various tools. The one popular tool is IDA Pro. Okay, there is a tool named Ghidra that is open source. IDA Pro is basically the paid version, but the free version is also available. So anyway, so after reverse engineering, we need to extract those features, or we can directly apply on this static analysis. We are going to map it in some matrix form, and then that can be directly used for the CNN network. Or we can go with the supervised features that we extracted from the reverse engineered file, and then the usual approaches that we follow, that we have followed throughout the series of the session, uh, that we may follow the pre-processing, whatever pre-processing is required, we can go with that one. And then this can be, if it is a kind of CNN model we are talking about, so definitely that will be in terms of images. So we are going to map those data in terms of uh, that matrix. Okay. So then these images will be finally input to the that CNN model, or it may be your deep learning model, deep neural networks, it may be the multi-perceptron model. So whatever model, uh, I'm not talking about this particular one. So it can be either your classical machine learning algorithm, or it might be the deep learning variants. Okay. So this example is pertaining to the CNN only. So the previously I have talked about the malware analysis. So this is the thing I was talking about. So if we are having a binary, we can convert it into 0 1 grid like this metric structure. So it will be kind of black and white images, the frames, and those frames will be input to the CNN architecture. And from there, the feature learning and all the classification tasks can be attained as usual. Means it is more like applying. We once we are ready with the data, we are going to apply it to the some models. Okay, but the thing is, we need to basically figure out when to use which model. Okay, which variant will be more suitable. So the next thing is, so whenever we talk about applying the deep learning based solutions, so we need to clearly basically have some boundary between different areas and how we are going to deal with. So let us first discuss what are the problem domains in cybersecurity, and then later on we will move into what are the different approaches that authors have basically applied. Okay, so if we talk about the cybersecurity, so cybersecurity can be basically broadly divided into three parts: the malware detection and analysis, the intrusion detection systems, and um, uh, whatever there is remaining. Okay. Now, so this malware detection analysis can be either PC based or the Android based malware. So there the solution could be in form of detection, classification, or analysis. Okay. And the approach that we may follow may fall under either the static, dynamic, or the hybrid one. Okay. So what this static dynamic hybrid means in terms of detection, classification, and analysis means the way we are going to use the feature that we have extracted from the previous this part. Okay. So depending on this one, we may opt for one of them. So this is the end level. This is the strategy that different DL models. Okay. Now next is intrusion detection system. Okay. So in intrusion detection system, in intrusion detection here, so it is also an anomaly detection, but there are version of this one means whether of based IDS or the anomaly based, or it is a hybrid one. Okay, is it a network based or it is uh, those kind next gen we are going to implement those this idea. This that is also we can say there are various version of that one, that is the host or the network level. Okay. Again, the problem could be basically seen in terms of detection and classification. Okay. And the other problem domains are basically the phishing detection, the spam detection, and the website defacement detection. Okay. So these are the broader aspect of cybersecurity, and each of them are basically nowadays being dealt with the by the application of this deep learning based algorithms or the variants of the DL. Okay. Now, so there are different we can say the broader areas in which we apply this DL algorithms. Okay, the one is security, the other is infrastructure security, the other is privacy. So there are various domains in which we apply. Now these are the basically the papers that has basically worked on basically different what we say algorithms of deep learning. So here these are the solutions provided for anomaly detection in wireless sensor network and network-based anomaly detection system. The spectrum anomaly detection wireless. So these are the paper that uses autoencoder, while the other stack-based autoencoder. So they are basically going to stack autoencoder multiple times to basically propose the solution for the same the means fog attack detection for fog environment, the network for IDS for IoT, the DOS attack for IoT, the anomaly detection for wireless devices. Then we have that the variational autoencoder also. Okay, so for that one, if you are aware about this variational autoencoder, is nothing but a kind of a generative model, we can say the probabilistic generative model. Okay, so then we have Boltzmann machines. Okay, so the malicious code detection. The authors have also used the PC. So these techniques are also used for network security situation awareness by working on the features of the data or the samples that we are having. Okay, and the other variants are softmax regression that has been applied on IDS. Okay, so likewise we have the solution based on artificial neural networks, but they are very much limited nowadays. Means recently it is very much limited. The multi-layer perceptron is also fine. It is being used, but not as much. I can say this that CNN, the deep neural network. Okay, so the LSTM. Okay, so now if I ask you a question, if you are clear about the concepts earlier we have discussed in the LSTM, what kind of means data will basically motivate us to use this LSTM? What will be the underlying data if we want to use this LSTM? So basically it we can use it for the predicting the footprinting of an attack. If we have a series of samples and we want to predict the simple future value or the step, so there in sequential data we can go with the LSTM. Okay, so deep belief networks. So we have other different variants on this one, like we have CNN variants. Okay, so these are the methods that authors have applied recently uh, for infrastructure security. Okay, now so we will talk about what this. So there are three verticals: the infrastructure security, the software security, and the third one is the privacy. Okay, so we will just see what we will see in the next slides. What this basically security areas uh, covers. But let us just confine with the methods that are basically used to tackle this to cover these areas, the security area. Okay, so if we talk about the software security concern, so whenever mostly these are the malware based situations. Okay, and there we might have some loopholes in our softwares. Okay, so due to that loopholes or vulnerabilities, there might be some leakage or there might be some zero day attacks being performed on your system or on infrastructure. Okay, so in order to propose the solution for software security, the authors have used the autoencoders variant. Okay, so if you will observe here, most of them, whenever it comes in terms of software, so it is mostly about the attacks that are caused by the uh, software vulnerabilities. So if there is some loophole, someone, some files must be there to basically exploit that loophole. Okay, so that is where the malware comes into the picture, and mostly all the solutions and the model they have used are basically targeted toward the malwares. Okay, so here the authors have basically targeted the malware, so it can be either the that Windows, Linux, or the Android based. Okay, so then developed networks has also been used. So and again it targeted the malware attacks. Okay, same the LSTM has also been applied. um, many number of many authors have applied the LSTM, likewise the CNN, and combination of LSTM have been applied. Okay, combination of CNN with RNA has also been applied in many of the research articles. Okay, so there are multimodal architecture for dealing with the malware detections. Okay, so uh, here you might be seeing the Android, but it is irrespective of what means source you are covering. Unless means if you have the proper source of data, we Okay, so sorry for the interruption. There was again a power cut. So let us continue from here. We were talking about this one. So uh, nowadays, as we are aware about the mobile networks, okay, so and the kind of software we are using for each of the application or each of the task, we are using a new software, and there are hundreds of software for the same problem. So definitely the malwares will be coming from those loopholes that are there in those softwares. Okay, so most of the solutions the recently the authors have covered basically covers the malwares. Okay, the botnets, that is one of the difficult or most difficult task to basically detect the malwares. Okay, and again the other one is the ransomware attacks. Okay, so this is again the most the popular one, and every country is now facing this ransomware attacks. So even the government are all the governments of different countries are working to basically mitigate or handle these situations. Anyway, so the thing is, so if you are means interested, you can either go with the Windows based malware analysis or detection, or you can go with the Android based application, uh, the cybersecurity domain. Okay, the third one is this is a very less explored area using means applying deep learning. So basically, I have talked about three verticals. The one was the infrastructure, the other one was software, and the third one is the privacy. So mostly, if you are aware about the encrypts this cyber security, the one domain is information security, where we talk about the privacy. Okay, and CIA trads. Okay, confidentiality, integrity, and availability. Okay, so this privacy is mostly attained using some kind of encryption. Okay, some kind of cryptography mechanisms. Okay, so this particular domain is very less explored, but yet there are works that has reported some of the novel work that tries to cover this privacy part. Okay, so you can just look around. So the mostly the papers have basically covered the models like multi-layer perceptron, the CNN, DNN, and LSTM. Okay, okay. Now, if we talk in terms of what do you mean by this infrastructure, what it covers. Okay, so before going ahead, let me just call basically this. If we talk about this API, this malware solution, so the deep learning, the data may be sourced at different level. Okay, the one may be the at the API level. Okay, the other may be the opcode level. So just wanted to confirm whether I am audible or not. Am I audible? Anyone, please? Am I audible? Hello. Okay. Thank you, Nishant. Uh, so basically, basically, uh, whenever we talk about the malware, earlier we have talked about the source, isn't it? This was the source. Okay. Now most of the authors have targeted this malware kind of things. So whenever it comes to the software or privacy, it is mostly the malware. So what are the levels from where we can have the data? What will be the source? Because deep learning works on data. Deep learning, any machine learning, deep learning, any AI tool works on the data that we are having. Even our learning is also based on how much data we are having to train ourselves. Okay, so definitely that malware whenever we are working with the malware, we need to basically identify at which layer we want to apply the DL, the deep learning methods. Okay, so the first one could be the API calls.
So mostly, if you are aware about the Windows, how Windows works or any operating system works, so it is all about the API calls. Okay, whatever request we make, all the request goes through the API calls. Okay, so even if malware wants to infect your system or want to execute some of the malicious file, definitely they must connect it through the API. Sometimes it may be the rootkit, so might not be using the APIs, rather directly it is interacting with the kernel, but most of the time it is through API call. So basically one may source the data at the API level. The other one could be the opcode. So we have just talked about the static analysis. We have just talked about the that binary files of malwares. Okay, we can either uh, map it to the assembly code or the machine code. From there we can extract the opcodes, and those opcodes might be input to our the deep learning methods. Okay, so these methods are some way they are utilizing those concepts. Okay, so they have basically applied the deep learning models and at different level of data sources. That may be the API calls, the opcode level, the machine level, or the assembly level. So basically DOS attacks, distributed attack detection. Okay, and in the software part we have seen it is mostly about the malwares or the attacks that are basically evolved from the malicious softwares only. Okay, so and the third one is basically the privacy part, where there are different attacks that are basically targeting that are basically executing their motives using different ways, like side channel attacks, the privacy preserving uh, uh, approach. Okay, so these are the three verticals. You may first, if you are working in the cybersecurity domain, you will first have to decide which part or which domain I am trying to focus. So your research area must first identify in which part you are trying to work. Okay, and within that domain, what are the aspect on which you will work, what is the source of data where you are trying or you will work. So that you will have to first figure out, and then you must be able to decipher the meaning of the malware files that you have. And for that also, if you know to reverse engineer the files, okay, so you will be able to basically extract very much informative features from those files. And once we have those features, we will easily be able to apply the different variants of deep learning architectures and based on the need. Okay, okay, now, so if we talk about the most common applications of deep learning in cybersecurity, so you can just look around here. Okay, so basically the first one is the network intrusion detection. Okay, so the network intrusion detection is nothing but a kind of software or tool. It is similar to what we have the firewalls. Okay, but like firewall means unlike the firewall, it is having a more diverse database of what we say patterns, the attack patterns. Okay, and mostly in the earlier days, the ideas were implemented using like basically the decision tree based models or the variant of decision tree models. Why? Because of the requirement of interpretability. means once you are taking the decision that some connection is malicious or the intruder, definitely you should able to comprehend or decipher, or you must take decision correctly whether it is indeed a kind of malicious connection or not. Okay, so that explainability must should be there, that you also Rajesh sir has already covered the that the decision, how why that we have came to that decision. Okay, then we have the fraud detection. Okay, so nowadays this fraud detections are very much active. So we are now having even the caller tune we are hearing, that is all about this fraud and the phishing. Okay, so the fraud detection is another major area where the deep learning is being applied. Okay, the next thing is, and I must also say that this global fraud detection and prevention market is projected to register a CAGR of 18.19% during the year, means in the interval of 2022 to 2027. Means just imagine the uh, the fold that is going to be increased, means the amount of this fraud kind of cyber attacks is going to be evolved. Okay, the other one is the cyber physical system. Okay, and before that the user identification and authentication is also there. So we are using that biometric based systems. Okay, so those are the areas where we are using the applying the deep learning methods. Okay, and there are various methods. If you will explore the literatures regarding this one, you will find a large number of literatures being published in the biometric and bioinformatics area. Okay, the next one is the cyber physical systems. Okay, so another domain where this cyber attacks are very much critical is the critical infrastructure itself. So the cyber physical systems are basically, we can say, the automated machines that are basically integral part of the system or the infrastructure. Okay, so they are basically forming the whole infrastructure, and our livelihood, means we can say our uh, we are directly or indirectly we are dependent on those infrastructure, like we can say the power grid, uh, or we can say there are various fields where it is being used, even in a refinery system, the power grids, uh, water treatment. Okay, so this is we call critical infrastructure. Okay, so the another popular area that is, even the government is promoting this area, means the cyber security proposal in the area of critical infrastructure protection. Okay, that will protect our power grids and refineries, the health system, health infrastructure. So these comes under the infrastructure. If once it is going to be compromised, it will directly affect the uh, its citizens. Okay, then the other field is spam filtering. It is not that much critical, but still the spams are the another area where we use this deep learning. And even if we talk what particular variant we have used, so you might remember it was a kind of uh, NLP kind of thing we can apply here. Okay, based on the content of uh, the mail, we can basically identify whether that mail is spam or not. Okay, so that way there are other techniques and there are other domains. So likewise we have encrypted traffic analysis. So there the CNN models are very much helpful to analyze the encrypted traffic, due to the nature of nature of the CNN. We can say it basically extract the information or the correlation spatially. So in that way the CNN is more relevant than other DL variants in case of the encrypted traffic analysis. Okay, and then the malware detection and analysis area is, again, we have what we have talked about in case of the software part. So this is, again, this is the malware is the very much dominating area. So most of the attack variant we talk about nowadays are somewhere originated from this malicious softwares only. Okay, so mostly we try to cover the malware, and eventually it will try to cover, or it will provide a protection against the other attacks to different domains. Okay. Okay, now if we talk in terms of IDS, so this IDS can be basically, as I have talked about this IDS earlier. So IDS, based on the place where we are going to basically implement or apply this IDS, it can be either centralized, distributed, federated. It can be the host based or network based. So whenever we talk about limited scalability, we go for the centralized one. Okay, the distributed one, we can go with different approaches. Nowadays we have the privacy concern along with this security. If we are going to basically talk about the privacy, so definitely the federated learning has emerged uh, very recently in this particular area. And now uh, most of the researchers in the cybersecurity domain, means we can say the larger portion of researchers are basically applying or they are exploring this federated learning area for this learning and privacy, both of them. Okay, now we are not only these three aspects, but we also need to basically make some trade-off between the speed, the privacy, and the level of scalability that we need. Okay, so we cannot blindly go with any of the approach. We need to first come up with the requirement of our system, and then accordingly we may just go with any of the architecture that we have. Okay, now, so nowadays you might have heard, so we are proposing the solution using deep learning models. Now the question may be, can deep learning models itself be vulnerable, or can it be poisoned, or can it be make vulnerable, can we build a end model that is vulnerable? Okay, so these questions are there. So definitely now you might have heard the adversarial attacks on machine and deep learning models. Okay, so these attacks, the adversarial attacks, can be further classified into different uh, categories, that is evasion, poisoning, and model extraction. So just look at here. uh, this is as usual procedure in building a AI model. So we have the data, we have feature vector, we trained the model, and there is the trained model, and then we test the data. Okay, now these three techniques, the adversarial attack techniques, differ in a way where we are going to apply, or where we are going to apply the adversary part. Okay, so if you look at here, just look at what we are doing. So attackers might be injecting some of the samples that might be malicious. Okay, but it is putting those samples in a training data, and saying that this data is genuine data. And once you are training on this data, saying those samples are also those sample also belongs to the genuine data, the benign group, definitely your system will fail at the real time. Why? Because those data has been fed by the attacker, saying that those were benign, but it was indeed malicious one. So this is the data poisoning. Okay, so it basically deals with the tampering with the training data itself. Okay, then the other one is the evasion attack. Okay, so basically we we apply some of the technique to basically bypass the model learning. Okay, so for this one, what we do, if you recall, just we have talked, and even there was a session on GANs. So you might have heard about the sample generation. So the attacker might generate some of the adversarial examples, either based on the current samples, the actual training data we have, or a complete new one. So what generally attackers do, they take some data from here, training sample, they apply some noise value in that one, and that will be used for training, and then that training will not be the exact training. So basically that might be misleading. Okay, so once it is trained, it might not be able to correctly predict the class level or whatever task it is intended for. Okay, now apart from that, the another category of the adversarial attack is the exploratory attack. So in this one, in the exploratory attack, mainly the attacker tries to basically uh, steal your model parameters. Okay, whatever parameter means, once you have trained the model, definitely you have fixed set of parameters. Those parameters won't change anymore, isn't it? Now, if the parameters are not changing, and if you get those parameters, that may help build a surrogate model that may be used to basically build a surrogate model that may be either replace the actual model, or it might be used in some different context, in some adversary context. Okay, so once these parameters are with attacker, definitely they learn the how your model is working. So they may basically trick your model accordingly if they learn how their your model is working. Okay, so these are adversarial attacks that we may have. Okay, so so how we can defend against these adversarial attacks? So definitely, uh, to make your model robust against the adversarial one, we must slightly modify the sample ourselves. Okay, so that those samples will be easily classified at runtime or in real-time environment. Okay, the second approach is, once you have downloaded or prepared your data, okay, that is coming from the third party, you must denoise before using it to training your model. Okay, so that is the another aspect. Then the one concern is, while building the model, we must keep on uh, our eye on the number of parameters that we are learning. So we must regulate the number of parameters that model is having, so that the model must not fail due to the overfitting problem. Okay, then the the fourth uh, part is the explainability. So we already, we are aware about different approaches that may be used for explainability. Since we are working in the what we say in a security domain, definitely explainability is a major concern. If suppose someone is booking a ticket and your model is saying that it is malicious one, so or it might be performing some very urgent task or transaction, and you have basically blocked it. So that false positives Am I audible now? Yes. Okay. So basically, we were at summary. Let me just go to that slide. Okay, so let me just talk from here. So basically, I was talking about the different models that are in use to propose the cybersecurity solutions. So among them, the RNN, the SNN, DRL, and GNNs are less explored one. And the reason why I have emphasized on SNN is it is in theoretically it is the lightweight. Okay, so if someone is interested in working in this field, definitely we are open to for uh, such a collaboration. Okay, so now whenever we talk about the challenges that we face in terms of cybersecurity solutions, the three things are there. The one is explainability, the other one is the lightweight solution, and the adaptivity. Okay, so we all know why these three things are there. Since it is all about security and there may be some critical transaction going on, so we cannot directly block it. We must reason out why we have blocked, so that if it is critical, we can be 100% sure that we need to block this one. Okay, and nowadays, as we talk in terms of cyber physical systems, so basically those cyber physical systems are the edge devices, a kind of edge devices. They are very devices that either works on batteries or they have less processing capacity. So definitely we need some lightweight we have came across some attack. The next day it might have changed some of the pattern it was having earlier. So your model must tackle those changes. Your model must evolve along with those changes in the nature of the attacks. So that is where the adaptivity comes into the picture. And the one major concern the cybersecurity people are working in is the data imbalance, how to basically handle the data imbalance. So most of the time, whenever we talk about the zero-day attacks or the attacks that have been recently uh, uh, known to the public domain, there are unlabeled data. So how we are going to tackle those things? So for that, can anybody suggest me what kind of model we can use to handle this data imbalance? Anyone? Anyone? Can you suggest me what kind of model we can use? What deep learning model we can apply for handling the data imbalance? So we may basically go with the what we say generative models, isn't it? The GAN you already have gone through. So we may go with the GAN models. Okay, that may be useful here. Okay, so finally, what we have seen uh, in this session is what are the different deep learning models, what are the different areas of cyber attacks, cyber security that are basically solved using deep learning models, what are the variants of deep learning models that are frequently being used, what are the deployment challenges that we have. Okay, what trade-offs we need to have. Then the deep learning model itself might be prone to some threats, and that we have just briefly introduced the adversarial threats or attacks. Okay, so basically I have suggested some of the points that you may uh, explore, that that we need to basically take care whenever we are dealing with uh, building a cybersecurity model. So definitely it should be immune to adversarial threats. And then there are future directions, means what are the areas in which we can work on. Okay, so this is all that we need to basically see. Going to propose some solution using deep learning for cybersecurity. So I hope this session was fruitful to you, those who are working in the cybersecurity domain. And if you still have some doubt, or if you want some if you further want to explore some of the topic, I may suggest some of the articles that you may refer to further explore the topics or the area in which you should work if you are in early stage of your research problem uh, finding. Okay, so with this we conclude the session, and if you have any query, just ask me. And finally, thank you all. So anyone, if you have any question or any query, if you want to discuss with me, you just put it in the chat box, please.
Yes, participants, if you have any doubt, then write in the chat box.
Anyway, I think it was all about application, what this deep learning application is, and how, what are the domains in which it is applicable, and what are the cybersecurity domains, how they are being classified. This is all the aspects that we have talked about. So hopefully it will be fruitful if you are working in this domain. So thank you all. Thank you for your patience. Due to some interruption, we have delayed the session. Anyway, thank you all. So we may conclude this session, and the next session will start.
Thank you, sir. Thank you,
Uh,
sir.
Welcome, Rajesh sir. Sorry for the delay. Actually, we had the power cut here. That's why the session got delayed.
Not a
Welcome
problem.
you.
Not a problem. It's okay. It's fine. Okay.
Thank you so much, sir. Okay. So let me just.
Yes, please just confirm the slide is visible.
Yes, sir. Visible, sir.
Okay, and I'm audible too, very clearly to you.
Yes, sir. Yes, sir.
Yeah, okay. Good afternoon from this side and good evening to the people who joined from India. Uh, I welcome you all in this session, and this is more towards reinforcement learning for robotics. It can be extended to any kind of application. The talk is more towards the reinforcement learning, and then the case study will be the robotics, where how it can be implemented or we can use it. Reinforcement is very popular, very established approach. It's a bit we nowadays people talk about. It's a third leg of your intelligence, AI, supervised learning, you know, then unsupervised we know, and then the third one is the reinforcement learning. And this is a well established approach, lot of applications, and it became popular when this happened, that basically that the Google team, they beat the world champion in AlphaGo game. So, and after that it became very popular. The approach was not very, or the mathematics or the thought was not very new. It's an old thought, but the way it is transformed or put in, it became popular, and then lot and lot of applications you can see throughout the world in different domain. Even ChatGPT backend, you will find one sector is they are using all these stuffs there. So few of the things which I can share with you. AlphaGo is one, then the another one is Deep Mimic. This one is basically trying to find out the movements or the motions, and then how the bot or how the robot can mimic the human behavior without explicitly trained on the data directly, but it is learning from the environment. and then depending upon the error it is making, it is modifying its own behavior and strategies, and then the actions, and then come out some new solutions there. There is another very good application. You can see the robots, they are playing with each other. They are not like they they are not designing that way that do this and do that. Some parts, some information is there. They play a lot of games, and by playing that, then they will learn. And this is the way we also learn the things. This is a much more complicated application. You can see there are two drones. Okay, on yours, one is red and another one is blue. You can check it there. One is human drone and another one is AI drone. This is a very one of the wonderful application where let me stop in between if I can do it. Yeah, it is embedded there. Okay, so the point is, see the movement and how fast it is, and the AI drone is not like a kind of a something which is done that way. It take a lot of trials, and every trial it take a lot of inputs, and from those inputs it try to learn the things. It hit the obstacles and then some penalty it will get, again next trial, and likewise. And by the trials and then learning and the penalties, it finally learn whole of the game, whole of the movement and all those things, and then it beat the human champion also. This is another application of reinforcement learning. You can see this is an Atari game, and you can see here initial phases there are a lot of errors made by the computer. Okay, and then after some training you'll find many trials, it keep on learning. You can see after 120 minutes of training, then it start playing like an expert. So it is basically learning from the environment rather than you take the data and then train the model and likewise. But how it will do is uh, we will discuss those sectors there, that how the learning is being done here and how the things become more and more uh, they become more effective. After many trials you'll find this become very innovative also, that it understand that what is the good strategy, what is the good plan to hit the ball. Okay, you can see now it's innovative. So this is how it is learning by that frame. Another application is by Dectel. You can see that the robot is solving a Rubik cube, and even if you make it blinded, still it can solve the things there. Okay, so that's another application of RL, which is again very popular. All these applications are where people have used reinforcement learning, and then the point is, what is the reinforcement learning? So the thing here is, and this is very good to learn a tool in or you can say it's a technology to work on the things where you have less data. The data you have less number of data, and then you want to do some kind of automation there, or you want to implement some kind of a mathematical operations to learn that how the data are interrelated and then come to some conclusion. This is a good approach. So how it will work in reinforcement learning, you will find there is an environment. So environment is the point here. You can say you want to learn chess, you want to play chess. So chess is basically an environment. Okay, and then you are playing the game. So what you will do, you will move one of the uh, either black or a white component here, depending upon which side you are playing with. So when you move any of the component here, so you are moving a white component, what you will get, you will either your white component, I'm taking as a component because there are so many things are there, there is a knight and the king and the queen and many are there. So when you move any of the component, either it will kill the opponent, or second it will be killed, or third it just do nothing. Okay, so these are the three things which will happen, and based upon these three things we will get certain kind of reward. Okay, so like if white will move forward, it kill the opponent, we'll say now the reward is positive because the ultimate goal is to win the to kill the opponents, and likewise immediate goal. If it is killed, we can say, oh, it's negative reward, and if it is not doing anything, we can put it some kind of negative reward, or very less negative reward, or zero reward, or likewise. And then the opponent will see your situation and it will play. And this is how we learn it, because we keep on doing all these things, we sum up all these rewards and the punishments, or you can say positive reward and negative reward, and at the end of the game we will see that how much reward we accumulated. Obviously if we win the game we will get the maximum, that is the ultimate goal. So what is there in reinforcement learning? There is an agent. You consider yourself an agent. That's the best way of learning reinforcement learning. Put yourself as an agent. You perform, and then what you will do? You do certain observations from the environment. You are going to play the chess. Then you will see that how the things are placed. You want to learn cycling, then you will see what will be the slope and what is the nature of the slope, and likewise. So those are your observations, and once you get the observations, then you take certain action, that okay, I'll move this, or I'll accelerate my cycle, bicycle or vehicle if I'm learning it, or something else. So once you take any action, you'll take action in an environment, and then what environment will do, it will send a certain reward. So if you're doing good, you'll get a positive reward. If you are doing bad, you'll get a negative reward. And this cycle keep on moving. And that is how reinforcement learning works. So just imagine, you know cycling, but you say you are the initial stage of doing your learning process, and some rainy day you are passing through an area which is slopey and a bit slippery also, and you move that the same way to take a decision, though you have observed that okay, there is a slopey area, and and but let's go like this, and then you will fall down. What the next step you will do? Next time when you will move through the same kind of environment, you tilt your body in such a way to make the balance and all that. So that is basically how you learn. So all these things happen, and that is actually basically the reinforcement learning. So we'll go step by step, learn few of the things, components, and then try to combine them, and then try to understand the various methods and algorithms people have developed over it. So I'll take this an example, that okay, in your search space, this is the search space, this is the area where some actions to be done. So there are some, you can say there are blocks, 16 blocks there. There is a monkey at S0, and there is a banana at S50. The job is monkey to reach to this banana. That is the basically the target, how it can reach to that point. So monkey can be at any of these blocks at any state, at any instant. These are known as states. That is the first term which you will find very common in reinforcement learning. That is the state. So you can find monkey at any of this position. Okay, so the initial start when you're developing this algorithm, you have to define what are your states. The next is action. So action here is monkey can go left, right, up and down. Okay, you can take it other way also, like you can say that okay, it can go up, down, left, right, diagonal also. Then your actions will be different, but in this case, let's say it can go at the left, right, up and down. So those are the actions it can take. Well, that is the second thing. Then the next thing is the transition function. Now the transition function, it can be two-way. It is in state S0, and if I say that okay, go towards your right, and 100% it will reach there. then it will be basically initially we can say deterministic kind of structure, that it will go there and stay there. But in real environment, things will not happen that way. Okay, so we attach a probability to it. Okay, and that is basically how we define the transition function. That, so what it states, it states that if you are in state S and if you decide action A, what is the probability to reach S dash? So this is basically how it can be calculated. Like it is in S0, decision taken is go right, so 95% it will go right. It may be possible that 5% it remain there. So that's what is mentioned here, that probability of going from S0 to S1 if action is taken as right movement is 0.95 and it remains there is 0.05. This function is known as a transition function. So transition function is basically attached or connected because of the putting the real scenario there. Okay, then we attach a reward to it. Reward is basically to make the things moving. Otherwise, if you don't attach any reward, why things will move? So monkey has reached to this point because once it reach here, it will get a reward of 10. Okay, if it is not reaching, it will get reward 0. So that is basically the reward is the ultimate one can say benefit it will get once the job is done. So how we define it, reward is a tuple which is taken as SA S dash. S means it is in state S and then it takes an action A and it reaches to S dash. So by doing this, how much reward it will get? That is basically the reward function. This is already there, initial state S0. There is another term which is very important and known as a discount factor. We will talk more on detail in the coming slides. What is the meaning of discount factor? Why we have added it? And then horizon is basically the whole episode and the work, how it will take place. So this is basically the framework and it depends on Markov decision process. So Markov process is basically that the future state depends on the current state regardless of earlier states and all that. So it follow that property. So anything, any arrangement which follows this property, it's more suitable for reinforcement learning, or we can modify that arrangement to follow this kind of a setup there. And then what is the goal? So the goal is to find a policy that will maximize the total reward. Now, don't get confused in these terms, but try to understand what is the goal of this monkey. The goal of this monkey is to reach this banana, because once it reaches this banana, it can eat, so it will get a reward of 10. It can reach by various ways. We know that it will, if it will take more, cover more distance, it will tired up, and then when it reach, it may not reach or may reach, but with not that of energy. So it has to find out a way which will give the maximum reward. So, and that is the policy to move from one point to another point. Okay, so that is basically the process policy here, that how we maximize this reward. So then now let's make it. Now we have to make a kind of a arrangements in our calculation. So say if I say that if you go anywhere you will get 0, and then if you reach here you will get 10. Well, maybe in that case the monkey will not move because it is not getting anything. So it goes here, it's 0, goes here 0, it goes here 0, here 0, and likewise, unless until we play a lot of episodes and it reaches here. Well, that is not a good idea to me. So what we can do is we do some modifications. Okay, and the modifications we do is, okay, what we can do is, let me move further, then I'll come to this equation. Like let's put 10 10 10 everywhere to make it move. Okay, so when the monkey move from this place to this place, it will get 10, so that will attract. Okay, and then again it will move, it will get another 10, again it will move another 10. And what is our policy? What is our goal? Goal is to find a policy which maximize the reward. So reward means when it will get 10, and then 20, then 30, and then 40, then 50, and likewise. So this is my reward. I want to maximize it. But what is the problem with this environment? If I go by this setting, monkey go here, S1, it will get 10, then it go to S2, it will 10, come back, again 10, go back, again 10. It keep on oscillating and the reward keep on increasing. It will never reach here. So you will stuck up. So this type of setting is not good setting. Okay, and that's why people come out with something which is more practical, because we need to make it the things in such a way that it should reach there. And there they introduce one kind of a term which is known as a discount factor, and this is represented by gamma. So discount factor means that if you move from this one to this place, you will get a reward, but then the next time frame you will get a discounted reward, and the next time it's a function of it, and that will help us because it will get a 10 here and then it will come back again. Then now the discounted, it's a not 10, it's a some percentage of 10. It keep on like, and this will, if you go to this expansion, you'll find it converge make the convergence, and it will help us to reach there. Finance people connect this thing with the money, and that is basically you can understand this way that the value of money as on today and the value of the same money after 2 years, it will be less, and that is basically the discount factor comes into the picture. So the value of the state means in this state, it until it reached to the goal, it can be calculated like this. Okay, how this will help us, it's a very interesting thing here. So what I can do is I write down this equation like this, and then what I can take RT, I take it like this, gamma I take it out and put these things in a bracket, which is nothing but V of S dash. Please note it here. Let's check it. You can take it here. I take gamma out of here. Okay, and then cut the gamma power from everywhere. So this term which is here, it's nothing but V of S dash. That is the meaning here. So now you can take it, we can say Vs is nothing but reward, that is the immediate reward plus the discounted future rewards. And this is a very important terminology. You will find a lot of people talking about in health sciences, okay, in decision making, what you are looking for. So if your gamma is 0, you are looking for just for immediate reward. If your gamma is very high, then you are looking for long-term rewards, and likewise. Okay, so that is how you can make this equation better, and this will help us making a policy. Right now we don't have any policy, but just we are finding what is the value of each state. Okay, now the point is here. Now how it will come, let's see. If I have, okay, let's do it like this. I don't know if it is visible. Okay, so now let's say initially reward everywhere is 0. Okay, and then gamma is 0.9. Okay, and now somehow the monkey reach from this place S14 to S15. Okay, so now we can easily calculate. So when it moves from S14 to S15, so the reward is initially everything reward is 0, but it is a gamma times that, which is 0.9 times of the value in new state, and value in new state is 9. Oh, sorry, 10. So 10 into 0.9, it will become 9. So these two states become 9, and then these states become 9.9 times of 9, and they are 0.9 times of 8.1, and likewise. So now you have values at every stage. if I follow this equation. And once I have this thing, now I can find out my action plan. If I am at S1, what is goal? Go for the higher reward. So if I'm at S1, what is the reward near around? This side, S0, it is less. I'll not go. S5, I can go. S6, I can go. And then if I go, oh sorry, S2, I can go. If I am at S5, then either I go to S6 or I go to S9. If I at S9, I'll go to S10 or S13. If I at S13, I'll go for S14, and finally I'll convert. So that is basically how the action take place. Okay, so now we have action plans based upon the value of that particular state. And if I follow that, move in that direction which give you a maximum reward, I have finally I have path, I have policy which give me the solution that how to reach at the goal. This is how the learning occurs. Okay, this is a greedy policy. Okay, greedy means we are just checking what is the immediate rewards and then maximizing that one and keep on moving. Well, in this case, what we are taking is, if I say go this side, it will go. But what we initially discussed, practical cases, it will not happen. So what to do? We can modify this equation. Okay. So what we are looking for right now, we are looking for this. This is my value function. I'm looking for a function or values in such a way that will give, or I'm trying to maximize my values so that I'll get a correct action. Or you can say I maximize this whole equation in such a based upon the actions so that I'll get my maximum value. But and this is deterministic. Deterministic means if I decide that go this side, it will go. But actually it is not happening. We have already discussed that. I say monkey, okay, I'll say that okay, move right side, but it may be possible that 20% it go this side, 80% it will jump to the next one. It may be possible, and that is actually non-deterministic, and that's why you put a probability there. So now we have to modify this thing, this equation, which is here. This is optimal value function, but it is only for the deterministic. Let's make it a bit stochastic or realistic one. So what we do is we can't say that maximize this value. We will say maximize the expectations. So this E here is the expectations. These are my expectations. Okay. If I say maximize my expectation, it's more realistic. And then how we write in a better way? We write in a better way that we multiply that old equation, value equation, by a transition probability. So what we are maximizing is we are maximizing this sum. And now we have this one, this equation with us, which is basically a Bellman equation. So this one is this one is our policy. So this pi representation is a policy. Okay. And this one is generalized Bellman equation, which controls whole of your reinforcement learning. Okay. So let's understand in this through this backup diagram. You are in state S. You follow a policy. So this is a policy. Okay. Pi is a policy, and what it is, given a state S, what action you are taking. So all these are actions. Okay. One action, second action, third action. Now depend, and you are in state S. So you follow that this policy that okay, if you are in state S, take action 3. So now you reaches here. This is the meaning of this term. And if it reaches here, okay, now it will, that is what we have taken, but it will reaches some state S dash. There are many S dash there. So what is the probability it will reach here? That comes here. And once it reaches here, then it will get a reward of this whole calculation. Try to understand it. You are here. This is the policy you are taking. Based upon that, you are taking certain action. And then that action will end up another new state which is associated with the probability. It's not like 100% you reach there. If you are reaching 100% there, in that case, this probability become 1 and it will become a deterministic. And what is the optimal? Optimal is if I, out of all these, I'll take the best one. So I'm maximizing this out of this one. So this is one, this is another, this is another policy. What is the best policy? And that is what we are looking for. Find a policy that will give me the maximum reward. Okay, so now just summarizing this part only. What is required when you are working on the things? We need states, define your states, define your actions, transition functions, rewards, initial state, discount factor, horizon, value function, we know the equation, and Bellman optimality equation, that also we know that. So this one is a Bellman optimality value, general value function is this one. These are the basically, if you talk about MDPs, which are a baseline of your reinforcement learning. In reinforcement learning, there are so many methods. Let's understand that ontology. What are those things and how people have taken it? So we can divide your RL in two categories. MDPs, that those are Markov decision process, and bandits. These are basically a slot machines, single point action kind of these things. So we are not talking here. We are more talking towards this kind of arrangement, which suits our robotic problems and other process control problems or power management problems, all electric problems, even in your machine learning, while you are solving some kind of decision making and all that, we are towards this side. When we are talking about MDPs, we have two sections there. One is model based, and then another one is the model free. Model based means we have a knowledge of a model. Okay, so the model knowledge is our environment is known to you. Okay, and model free means that environment is not known to you. So now this one is interesting, that okay, I'm making autonomous vehicle, and I'm putting it in an environment which is not known to me, and I expect the vehicle to learn of its own. Model based means everything is known to me. Okay, in model based, again, then we have two sections. Okay, model given and model learned. Well, in one case, the model is given to you, that okay, this is the model of the where you want to apply this whole setup. The equations are given, the physics is given, some kind of a molecular configurations are given, some connectivity is given, some relations are given to you. That means you have idea about the model, and then you have to learn from there. Model learned means I don't have idea about the model, but I have some data patterns. I have some X input data, I know Y input. So from there, I learn the model, I develop the relations, and then the model is known to me, and then I apply RL algorithms. I mean, after that, I'll develop my models there, RL models and other processing I can do it. In model free, there are two categories. One is value based, another one is policy based. I'll explain you in future coming slides what's the difference. Value based means we work on the values of the states. So we find out a policy. Try to understand, this is a confusing, most of the time people get confused. In value based, we try to find out a policy which gives me the maximum value. Okay, so it is basically we calculate the values, and then from there we try to find out the policy. In policy based, we have many policies and we pick the best policy out of it. So here the objective function, it is basically a different, that out of these policies which is best. So it's more of an optimization problem, that this is the or max. So and that is a difference here in those two approaches. In value based, we have the values, and from there we find out the policy. In policy based, we have so many policies, and then we try to find out that policy which give me the maximum value. Okay, I'll explain it mathematically also so that we can have better picture. And then the subdivision is there. In value based, we have two approaches: on policy and off policy. On policy means the policy which evaluate the behavior and which is learning. There are two things always. One, we use a policy to learn, and the second, we use a policy to evaluate the behavior. So in on policy, both are same. The same policy is used to learn and the same policy is used to evaluate. In off policy, they are different. Learning is different than the evaluation policy. So that is the off policy. In policy based approaches, I told you it's a more optimization problem. Optimization problem can be divided into two categories: gradient based, where you go for the derivative. We know that to find out the maximum, what we do, we just take a differentiation and equate equal to 0. So and if you want to solve it iterative way, so we find out the delta factor and then keep on adding to it. So that's a gradient based. Gradient free means we are not calculating any gradient. We can use some kind of other approaches. Okay. So this is how this structured, and you will find all these are the methods which are available there. Like on policy, we have SARSA method. Off policy, we have Q learning, deep Q learning, double deep Q learning, CS51, dueling DQ, and gradient. We have cross entropy, evolution strategy. Since this one is an optimization process, so people talk about using meta-heuristic or heuristic approaches to find out the solution. In gradient based, they find out, do all these things using the gradients. So these are the approaches like policy gradient, TRPO, PPO, DPG, A2C, DT3, and SAC. We'll see how much we can cover, but I'll start from some part of it. Let's understand the two parts which may confuse. One is the value iteration and another one is basically a policy iteration. So I'll go to the example here. Okay, so just formulating a problem in a different way. So this is the robo here. This robo has to move to this endpoint S11, which S11 to charge itself. So if it reaches at S11, it will get a positive one, but near to around there is a heat area or there is a fire. If it reaches here, it's a -1. This S5 you can see is a blocked one. It cannot go there. So it has to go either this way or this way. Rest of the point it is 0, and the action plan is up, down, left, right. So that is how the arrangement is done. So we have fixed the states, we have fixed the action, we have fixed the reward. We have fixed all the components there, and then we have these transitions that is basically deterministic. So deterministic means if it is in this way, this block, and we give a command that go down, then 100% it will go down. That is a deterministic. Stochastic can be like if I ask this bot to go down, it may remain there, or it may go left, or it may go down. So that is stochastic that we have discussed here. So that is basically the probabilities. So now this arrangement we have fixed here that if bot is in state S and we ask the bot to take any action, so 90% it will follow, but 10% it remain there. So this is what we have fixed. Transition probability we have fixed here that 90% it will follow, 10% it remain there. Okay. Okay, and then we are looking for an optimal policy. You can see the search tree here that it is in state S. It has many actions. It will choose one of them, and then once it reach here, it's a quasi state. It reaches to the next S dash depending upon this probability. Once it reaches there, it will get a reward. Okay. So now our goal, we are clear with our goal. This one is already I have explained to you, and it is basically it follow a search tree. So it's here, quasi state, it reaches here, get a reward, then take another action, quasi state reaches here, get another reward, quasi state reaches another reward, and likewise it reaches there. This one is MDP search trees. So discounted reward, and there are theorems which prove it that it will be a bounded term problem. Okay. Okay, so let's move to the part here when we are talking about talking about a few things which are very important for us. So let's go to the mathematical part here. Now I'm talking about value iteration. Okay, so value iteration, how it will calculate. Now we know that this is our equation. Okay, so say this is the initial setting, and say somehow your this S10 it reaches from this to S11. So how we calculate it? So value of, okay, in the second V2 here it's the second iteration, S10 is the location, which is equal to what? Transition probability moving from S10 to S11, which is 0.9. So I'll take 0.9 times reward is 0 initially, so that is 0, and then gamma is also taken as 0.9. So it's a 0.9 times the V of S dash, which is 1. This is this calculation, but 10% times it remain there. So 0.1 times of R is 0, and it remain there, it's also 0, and I calculate this value, it will be 0.81. So here it comes 0.81. Try to understand this factor because this is very important here. Okay, similarly you can calculate S9. So S9 also follow this one, you can check it here. It is 0.9 times it go forward, so it's 0 plus 0.9 times of what is the value, it's a 0.81. So it is 0.81, and it will do this calculation when it is in this iteration number 3. Similarly you can calculate for all the values. Okay, all the values, and you can fill up the table. Okay, you can have all these values calculations, the table will be filled up, and once everything is done, then okay, let me see if it is stabilized. So you will find if you plot this curve, it will stabilize after some time. Like this is S0 state stabilization, S1 stabilization, S3 stabilization, and likewise. So once it is stable, then you will find there is no change in the values. Once there is no change in the values, then you can find out you are here. Now you can find out the path. So which one is high value, 0.67 or 0.62? So either you can go this or go there. So if you are here, then you check out what are the near around values. So 0.7 is more, it will go there. Then again it will check what is the value. It's 0.62 this side, 0.62 this side, 0.79 this side, it will go down. Then again it will check which is a high value, and then it go left. So either it will follow this path or it will follow this path. The reward both ways same, and hence the robo automatically reach to the or it will learn to how to reach to this this endpoint. And this is basically, you're from computer science, it's more like a dynamic programming. That is what we are doing here, but this is value iteration. Okay, we are calculating the values. Once the value is known to us, then we find out the path and to reach at to the goal there. Okay, there is another one which is policy iteration. I told you there are two ways to do it. In policy iteration, what we have, we assume some policy, okay, and then evaluate the policy, and then improvise the policy. That is the difference between the two approaches. In value function, we calculate the value and then find out a policy that will give us maximum value. But in policy iteration, what we do is we assume some policy, evaluate what is the value, and then improvise it. How it is different, let's understand it through a mathematical example because it may confuse you here. Again, we use the dynamic programming kind of stuff here. Okay, So now the thing is here, like let's say we have assumed that wherever we are, we move towards right. Okay, this is the policy. Okay, so nothing will happen at these places, but something will happen at this S6 and something will happen at S10. Okay, S10 I can easily calculate by the same way, because now I have decided the policy, but I have to evaluate what is the value. So value evaluation will be the same. S10 will be 0.9 times of 0 on value, 0.9 times gamma is into 1 plus 0.1 times where it remains, and then rest of the things. Whereas if I calculate the value at S6, you can see it will be, instead of 1, it will be -1 here, and if you calculate it, the value will be like this. Okay, once it is done, once we are okay with this one, then what we can do is we can check it. Okay, we can have other values there. Okay, we can have some other calculations. First iteration v1 for 10 and 6, then we calculate v2 for 10 and 6, and please note it here, this was the 0 initially, here, and then the value keep on changing here. Okay, if we keep on changing like this, okay, and we calculate the values for all the setup, okay, and once it is stabilized, okay, once this is stabilized, then what we will do, then we check them, we evaluate that which one is much better. So initially my policies are this, and now if it is stabilizing, then we check it. Okay, 0 to 0 it's okay, 0 to 0 it's okay, 0 to this is not okay, and this other things are going good. So what we can do is we can modify it, because this is not good, because if it is there, you just check it, what is happening, what is the issue. This one is fine, okay, but if I take this action, it will go to the more negative value. That means this one is not a good plan, this point is not a good plan. So I change my action plan here, that instead of going this, I go this side, and as you decided, I go this, again we will do the whole calculations again. Okay, and then you will find a better plan, that okay, now the value is this, and we keep on doing like this, and finally what you can do is, after certain iterations, you will find you have a complete plan. Oh sorry, I think that slide is not here. You'll find that they are stabilizing in a way that this is a better plan to go. This is basically policy based, policy iteration based approach. That's the effect here. So I decide a policy. So value iteration means I have a value, I calculate the values, based upon my values, I'll find out the policy. And policy iteration based, I decide the policy and then perform actions and then evaluate the policy and then modify the policy and then reach it back. That's the difference between these two approaches. Okay, so you can compare both the approaches, value based and policy based. So there are two loops in policy and there is a single loop in the value based. Both are very simple to implement, but they have a limitations, and the limitation is this one. This is a real challenge in this approach what we have discussed. They are simple, they converge very fast, but they work only good when we have a complete knowledge of the environment in advance, which usually is not there. We have to, usually the environment dynamics is not known, and then that's why you have to modify these methods. Okay, so then comes the introduction of a new thing, and that is basically known as a Q function. So now we are modifying your V function to another function which is known as a Q function. And Q function is basically states that if you are in any state and you have different actions, so what is the value of the combination, rather than only depending upon the state values, what is the value of a state and action combination? And that's the correction here. So if you check the earlier slides, it was only V is only function of S. Now Q is there, and which is a function of state and action. So this what it state the expectations over the reward with the state, given state, and taken action taken there. So here is a difference you can see here, and this is basically a good way to make it learn. And they say that if I introduce an interesting part here, and this part is basically this part, if I take it as the maximum, so what it means, let's understand it. It means that if I know state action combination, so why should not I take that action which is giving the maximum value? So that is basically how it comes here. And if I follow this type of learning, this is known as a Q learning. Okay, so this is very popular. It is a Q learning approach. And we use basically here temporal difference learning. Okay, you already aware of it. You have used it in your all machine learning or AI algorithms. How you do it? That initially you have certain value, and then you update that value by a learning factor multiplied by the error there. That is how you update it. So the same approach is used here, and this makes things life easy. So how it is working? I don't know what are my Q values, so I randomly take any Q value, and then that is the initial Q value which is here, and then I update it. So update it by I add a learning factor alpha. This is what I am expecting, and this is what I am getting. So there is always an error between expectations and what I get it, and this difference I use it to update my value, and I'll get a new value. And in the next cycle, this Qi plus 1 comes here, and all these things I calculate it. So every iteration I keep on learning. And if I don't have an idea of this, how I'm getting this QSA, so estimate it. So if the MDP, Markov decision process, is unknown, I estimate it. If MDP is known to me, I just compute it. That's all. This type of learning is known as Q learning. We have a concept of a dynamic programming which we are using here. Temporal difference is being used here. Okay. So now we are talking about the algorithms. So let's talk about the first on policy algorithm, and then from there we try to connect more complex algorithm. This is SARSA. What is the SARSA? SARSA means state action reward state action. That's the name here. So you are in state S, you take an action A, and then you reach to state S plus 1, you get a reward, and then you take a new action. This is basically the SARSA model. Okay, and then in SARSA, how you do it? Okay, so in SARSA, you do it this way. Now try to find out I'll show you what's the difference. You have Q, state action, so initialize it by some value, alpha. This is what is you are expecting, this is what you are getting, you update it, keep on updating. Once we have every knowledge of Q, then we go for argmax A. Argmax A means then we take that action which gives me the maximum value. That is the SARSA. Okay, and then there is a Q learning. So don't get confused. Q is a representation of a quasi state where we have information on both of state and action. What is there in a Q learning? I'll explain to you. What's the difference there? So Q learning also same, but here you will see that it's not SARSA, it's a SAR. You can SARS state action reward state. And what is the difference here is between this one and this earlier one. This is basically a kind of a greedy one. So here what is expected is basically you see that max is put there, that out of various give me the maximum, that direction, that action which maximizes it. So that's the difference between the two approaches. Okay, so how it will work? Let's talk about the Q learning, because if you understand it, then the rest of the things are also very easily understandable. So this is the okay. This is the this is my pseudocode of Q learning. This is the Q value, alpha times of R plus this one minus this part, which keep on updating. So let's take the example. My actions are discrete, my states are discrete. So there are, you can say, 10 states, because S5 is you can say assume it there are 10 states, though the states here are S0 to S1 is a concluding state, 11 is, so we don't consider it, so you can consider the rest of the states, whereas S5 also you can eliminate it because it cannot go there. So you will see that in this plan S0, S1, S2, S3, S4, no S5 because you cannot go there. 6, I don't know why I mix 7, so 7 is the ending state, so that is also not there. Then 8, 9, 10, 11 is also not there. So we remove those states which are ending states basically, or prohibited states. And then on this side we have actions. So this side action, right, left, up and down. So initially everything is 0. We start randomly at any place. Okay, and we take any action there. Okay, so like here, S0 to S9, if I take it, okay, so I'll get certain value there. So somehow I reach to this point, I fill it like, okay, at this state I have 3 actions, and then out of those 3 actions, what is the value? So at any state like S0, S10 is here, so it has left, going right is one value, going left is another value, going up is another value, down it cannot go, it always remains 0. So it'll calculate all the values, okay, and it will fill this whole table. Okay, once this table is filled, then the things are very easy. Now you can start from any point. So if you can start from S6, you will check it out which one is in this row, which one is the maximum value. So say the maximum value is going down. Okay, so the action is going down, so you move from this to down. Down is S10, then you check it in S10 row, which one is maximum value. So the maximum value is, say, going right. So going right is you reach here. This is basically how the Q learning works. Well, this arrangement is good. It had certain problem, this because this is a tabular method. You have to develop this table, and if this table designing is, what is the issue with this table designing? It varies. It varies from designer to designer. If my process is continuous, say in robotics I'm working on, my process is continuous, then what will be the size of the table? So if it is a function of time, if I take a step time 1, then if it is 10 seconds, then the size, you can say, okay, 10 blocks. But if I take a step size of 0.1, then there will be 100 blocks. And if I take 0.01, then it will be 1000 blocks. So it totally depends upon the person to person. And it may be possible that when the event is continuous, there is a situation when the value lies on the boundary of the two. So how to do that one? And then it's a big structure. Just think of a robotic problem when it's a continuous and there are 10 variables, and we have to take a decision for an event of 5 minutes, or say with a span of 0.01 second. Now you can think of the size of the table, and then calculating all those things is a bulky. So what is the solution? And the solution is, can we use an approximator? Can we use approximation technique? And one of the good approximator is a neural network. So can we introduce a neural network here? So how you can introduce the neural network in this problem? So I develop a neural network. I give one input as state, another input as action. It give me the value. That's all my problem. And that's how people move from this to this, because I'll come to that part. But let's compare the two things there. What is the difference? In SARSA, there is nothing like max here. And in Q-learning, we have max. That's the only difference between the two. Okay, greedy and non-greedy. So in SARSA, my update is on the same, evaluation is also the same. But in Q-learning, my update is another one, and the evaluation is on the another one. So that's how people. I'm continuing that one, not going to break the discussion. So people thought of using neural network, and that's why that is basically DQN comes into picture. That is deep Q network. Okay, so what is there? Take a simple example of this block. Water is coming from here and water is exiting from the bottom side. I want to maintain this height constant. I have to control this. So now what is happening? I know what are my states. But now it's a continuous process. Water is continuously coming, continuously going. So the states and all these things are continuous. Actions can be discrete, but later on we can think of actions also can be continuous. Okay, so in such kind of a thing, there is a problem. Okay, well, the thought is, let's make it put a neural network here. So what are the input to my neural network? States and the action, and what it will do, it will give me the Q, that is the quality, that is the value of that particular block, that for this state and action, what is the value. But now this Q is no more simple S and A. Try to understand it. This is S, A, and theta. Please let me know how much time I have. I keep on speaking, otherwise. Can anybody suggest me how much time I have? Let me check it.
So you can go ahead for 5 or 10 minutes if you want.
For next 20 minutes?
5 or 10 only fine, sir. Because then they have a validatory session at around
Okay, 10 minutes
9:40,
only.
40.
Okay. Okay, 10 minutes I'll take it and then I'll close it. Okay. So now this
Okay.
Q is no more only function of S and A, it is also function of theta. And what is this theta? This theta are the weights of this neural network. So that is exactly what is now happening here. That is the new parameter. So now this is a neural network which I'm using to find out the value of that Q. So I pass the state and action and then train it. But now the problem is there. And the problem is I don't know what is Q. So how I'll train it? Okay. So then we can have this one. We can use this kind of we use this thing. We call it a Bellman error. This is what is I'm expecting. This is what I'm getting. So I initially start with any value, any random weights, get this value. This is the expected. I'll take the difference, and then I use this equation, which you are aware of. This is basically this is nothing but your weight updation equation in neural network. You are updating the weights. You can use kind of back propagation kind of thing. You are just updating the weights. Once it is trained, then this model is okay, and then I can solve this problem. But so since Q is introduced here, we call it's a deep Q network. It's an approach or it's a solving a methodology in reinforcement learning. But there are problems with this one, and these are the problems here now. First problem, which is very common. Neural networks, they are good if your data are IIDs. Okay, they are independent data. But in this case, the data which I am receiving, they are sequential states. Sequential state means they are connected with each other. If they are connected with each other, then they influence each other, the decisions. And if it is like that, then there is a problem with this kind of arrangement. The second thing is you are calculating this derivative. And this derivative, and when you calculate any derivative, so you are calculating derivative of some error. And in error, then if you are taking it, then one has to be fixed. The second can be variable. But in this case, what is happening? this one is also varying and this one is also varying. So target is also changing. And if you are try to find out a gradient of it, where your target is also changing, it will reach to instability. It will not converge, it will diverge. That is the problem with this approach. Okay, then people thought of like a solution that what we can do, and then they modify it. And they modify it by various ways. This is one of the way. They modified deep Q learning. They modified this version. They say that what we can do, instead of doing it continually, what we can do is we perform certain kind of experiments, play the game many times, or we have many various episodes, and for every episode we have certain solutions. So we keep all the certain values. So for all the episodes we have values, and then randomly we pick some of them and then apply this whole approach. So if I'm using this technique, I'm taking random samples out of it. It has many benefits. Number one, I'm taking samples randomly. That means I get rid of this one, sequential states, because they are taken now randomly. They are not in a sequence. So I get this part. And second thing is I'm taking the samples from the past experience. So that means I'm not ignoring what happened earlier. I'm considering that into my calculations. If you are using this approach, this means this we call it that we are using a replay buffer. This is the first version come to into it. You can see there are two loops. One is outer loop here, another one is inner loop. So here is a sampling, and the inner is same as like what happened earlier also. And then whatever the decision taken, we store it. Keep on storing here. But now still we have issue of that variable goal. That we can do it now like this. What we do it here is when running in the loop, one loop we move fast, another loop we move slow. That means what? If this loop, outer loop is slow and the inner loop is fast, that means for one iteration of outer loop, I have 10 iterations of inner loop. That means what? That means that for 10 iterations, the values which I'm taking from outer loop, they remain constant. Okay, so that is exactly what is happening there. And then to estimate all these things, they again use another kind of a structure there. So one loop is a constant for some time, and the inner loop is updating. So that's why they call it like, okay, why let's have a two neural network, one neural network for outer side, okay, which give me this kind of structure, okay, and the another neural network give me these values. This neural network I keep at outside, I'll update slowly. This I update it fast. So if I'm updating this fast, then to this network which I'm updating fast, this remains stationary. And that is what the new version comes into the picture. This we call it a version 2, but this is when this is basically exact deep Q network, DQN, where two networks are used there for the purpose. Okay, so going further, so this one is the complete structure. We use replay buffer. We use different networks there, two different networks for two different purpose, and then those things make the thing better, because now we don't need anything. We don't need any information. We don't need the information of the system also. We just take action, get a reward and next state, and likewise, and we keep on solving. This thing you can find this article which is published in 2013. Okay, but there are issues with this kind of arrangement also. Later on people observed it. I think I'll reach there and I'll take the case study, and they modify it. They call it a double learning. double deep queue network, DDQ network. Okay, so they go for a double queue network there. Okay, one queue network, another queue network, and in every queue network there are two neural networks. So actually there are four neural networks they will work here, because when they perform the experiments over many of these things, they find that the DQ1 is basically overestimating the things, and it will happen. Since we have a short of time, so I'm just not going to that depth of it, but it will happen. The approximation which is done by neural network, it over approximate the things, overestimate the things. Okay, and that is exactly what is happening here. So you can see here any of the figure, this is the true value, whereas this is what it is estimating. But when they go for double learning, you can see the estimation is very much near to the true value. And likewise, I'm just going to there are many actor-critic and all these things. If you search nowadays, there are many more than 100 such algorithms are available. I'm just explaining one case study. This we did long back, then we published this article. We did it on the real hardware in 2000, probably, if I'm not wrong, 12, and then we published this one. You can see a bot is there. This is RoboBot, and here are the two. You can see the two cameras are there. These two cameras are used just to make a stereo vision. Okay, this robot has to avoid these obstacles and move from one place, and it has to reach to the goal. The concept of Google car, we try to emulate that time. We haven't used any kind of a proximity sensors and all that. Otherwise you can use it, proximity sensor, it move, if it reach near to the obstacle, either it go left or right, and then it move, but then it move in their direction and keep on moving in that direction, which is not a good idea. Our goal is to move to this. So one camera can do the job, because it can identify the obstacle, and then it can go left and right, and then you can make a policy or decision making thought. But again, that is not reasonably good, because you cannot find out how far is the object. If you want to find the depth into the image, because a camera is just giving you images, then you need a stereo vision. So that's why we put two cameras, to have exactly like eye like impact. So that is the environment, this is the structuring there. Then we put a reward, that this whole area is into grids, and then each if it is moving diagonal, it is minusly rewarded, very high minus, and then if it is going straight simple, -1. If it hit the board, any obstacle, very high negative reward, and if it reach to the goal, very high positive reward. That is basically the reward mechanism. Actions are, it can take any action, it can take up, down, left, right, and all diagonal directions. Then we use for a policy approximators, we use neural network. Well, here our network is a bit different. We are using cameras, so it is basically we have used a CNN layer to identify the obstacles. Okay, so you can see this is a CNN arrangement there. You can see convolutions layers and all these things, and finally we have a fully connected layer. So the flow chart is basically the stereo vision camera. It is at any state, it will give you the images, and then deep neural network used as a policy approximator, it will give the optimal action. Action goes to the action will be only in the form of, okay, go left, right, diagonally left, diagonally right, back, and likewise. Then the signal goes to the goes to this this bot here. This bot is three wheeled. Front is free wheeled. Rest two are the motors. So it go to the PWM structure of that, which control the speed of the motor. And the movement is very simple. If it has to go straight, then both pulses to both motors will be the same. Both pulses will be same, so it will move forward. If it has to turn on one direction, so one side pulses will be more, another side pulses will be less, so it will take left or right turn or likewise. So those signals will go there, and then it will take a moment, it will reach to a new state, and based upon the new state, it will get a reward from here. And as also the new images will come, this reward then and the new state will give a new action, and it will work like that. This is the concept of Google Car we have realized in 2012. This was a final year project that we didn't have all GPUs and all these things. So what we have done is the work we did it in the Ramal lab, and we use our MNIT cloud computing facility. So we put the cameras there, we send the data to the local machine. From the local machine, we send to the cloud where we process it. Okay, at local machine, we take the convert into packages transmitted to the cloud server where we combine it, process it, and then get it back to the local machine, and then the action will occurs, and it works very well. So these are certain results. So here don't get these epochs. These are not epochs. These are basically number of the time the bot is allowed. So how the experiment is being done? We leave this bot and let it move. It moves and then hit the board. Then we bring it at again, leave it, bring it back, again leave it, so that every time it keep on updating its all those calculations. So here the term, it's not epoch, these are the episodes. So we found that these are the number of obstacles. We found that after 10,000 times we play this, repeat this exercise, this bot is able to get 100% accuracy. But here the obstacles are, everything is almost stationary. The obstacles are stationary, so it can just identify them, and then that's all. In the second case, what we have done is we make it dynamic. So in first case, it's just stationary, everything. It's a dynamic. So this bot is moving, obstacles are fixed, and then we did around 20,000 episodes. 20,000 times we play the same thing, repeat the same thing, and we able to get it. The last case is the most interesting one, where everything is moving. Meaning is the obstacles are also moving, bot is also moving, and obstacles are moving. And the first is when 2 obstacles are moving, the second is 4 obstacles moving, the 6, and the last one is the randomly, sometimes one obstacle, sometimes 2 obstacles, sometimes 3 obstacles, everything is moving. And you can see here, even after 1 lakh episodes, the accuracy is it's a quite good one still. Those days 96 or 97% we achieved it. But the good part here is now the machine is learning of its own. Machine means this robot is learning of its own, depending upon how the environment or environment complexity is happening there. It's not like trained in another some other way. Okay, this is how it works. So we are short of time. I have a lot of other examples, lot of case studies. This one is we applied it to hybrid electric vehicles, then we applied it to motors control, and this is basically home energy management. Okay, so I stop it here because of the short of time. We just discussed some basic modules, basic operations, and I'll take your questions if you have queries. Well, all these slides I have already posted on my page. You can get it from LinkedIn profile also. All these lecture slides are there, and all these models are also there, and probably you can get it from my website also. So I'm stopping this presentation right now and taking your questions. If you have any questions, please post it here, or you can write it, or you can unmute it. If you have any questions related to, we have discussed only few things. SARSA we have discussed Q learning, we have discussed DQN, and then we have discussed in a very brief DDQN. There are many more, like actor critic network, and then deep deterministic one. We haven't discussed anything on policy based what we have discussed today is only on the value-based approaches. Any questions if you have, you are most welcome. Yeah, okay. Just I'll share you the LinkedIn one. It will help you a lot because that time I decided it for you people only. Like okay, those who are interested. Okay, so you can 1 second. Okay, you can get it from this one. All videos right from the beginning, the same what sorry, lectures same what we have discussed. Few of them are animated one, so that you can check it, you can understand it, that how it works, and then some more complex one like which we haven't discussed, like actor critic or DDPG or A2C, and all those are also there, so you can check it from there. If still you have any questions, I already shared you my personal page as well as my number and mail ID, so you can write to me. I'll answer your queries. I'll happy to answer your queries if you have any more, anything more, any questions related.
Yes, participants, if you have any doubt, then please raise your query here, or you can write in a chat box. Very okay, so I think there is no query. So I sincerely appreciate Professor Rajesh Kumar sir for the insightful 1 hour lecture on reinforcement learning for robotics. Thank you, sir, for sharing your valuable expertise. So this
Yeah,
was
thank you, Dr. Surinder. Thank you very much.
thank you, sir. So your lecture actually was the 40th lecture of this FDP. Now we reach towards end of this FDP. So this was the last lecture and very impactful, very interesting, and you shared and you discussed the case study also. So thank you very much, sir. So if there is no query from the participant side, so now let me thanks to all and just formal this valedictory session. So now over this course of this program, we have had an incredible learning journey enriched by this expert of interactive sessions and meaningful discussions. So with over more than 75 enthusiastic participants from all over the country, this FDP has truly been a platform of shared knowledge and collaboration. So at this, we'll take a few minutes to extend our heartfelt gratitude to everyone who made this FDP successful. So a respectful and humble thank you to Almighty for giving us the strength, wisdom, and this opportunity to come together for this learning journey. So first and foremost, our sincere thanks to the Director of MNIT Jaipur, Professor N.P. Padi sir, for his constant support and vision in encouraging such academic initiatives. A special thank to Chief Investigator E&ICT Academy, Professor Vinith Saula, Coordinator E&ICT, Dr. Satyasai Jagannath Nanda, Co-Chief Investigator E&ICT Academy, Professor Love Bhargav, Professor Pili Emmanuel Subakar, Dr. Ravi Kumar Madila for their leadership and guidance throughout the program. So our warm thanks to entire staff of the E&ICT Academy, MNIT Jaipur, whose hard work and attention to detail ensured the smooth execution of this FDP. We also extend our heartfelt appreciation to Mr. Ashutosh Jana, especially research scholar. He is a research scholar in a Raman lab in the Department of Electrical Engineering, MNIT Jaipur, for his dedicated efforts, coordination on this WhatsApp group, and sharing everything, the material is emailed to all the speakers, to all the this, all the speakers, participants. Thank you very much, Ashutosh, for the participants. Gratitude to MNIT Jaipur Institute for providing the place this meaningful event. Sincere thanks to Department of Electrical Engineering and Computer Science Engineering for its academic. Really brought life to every session. It has been a pleasure to learn and grow together. Last but certainly not least, our heartfelt thanks to all the speakers. Let me name them: Professor Rajesh Kumar, University of Johannesburg, South Africa; Dr. Ram Prasad Pade, IIT Bhubaneswar; Dr. Satyendra Singh Chauhan, MNIT Jaipur; Dr. Mahipal Jadeja, MNIT Jaipur; Dr. Ashwini, IIT Ropar; Dr. Sonam Mishra, IBM Research; Dr. Abhinav Kumar, MNIT Allahabad; Dr. Sarup Ranjan Behra, Exxon Mobil; Dr. Neeta Nain, MNIT Jaipur; Dr. Vikas Kumar, MNIT Jaipur; Dr. Ashish Tripathi, MNIT Jaipur; Dr. Irshad Hussain, Shiksha Anusandhan; Dr. Deepak Ranjan Nayak, MNIT Jaipur. So, thanks to all the speakers who shared their knowledge. All the sessions were inside. So thank you all, thank you sir, thank you Vikas sir.
Thank you so much, sir.
So,
And just I would like to again, I would also like to extend my sincere thanks to all the invited experts from across India for graciously accepting our invitation. And hopefully, they have contributed their valuable insight during the session. So, and you have, we hope you have enjoyed the session. If you have some suggestion for our organization, if we have lag somewhere, definitely we would request you some genuine feedback from your side. Definitely, we will try to improve upon those things next time. And last but not least, the heartfelt thanks to all the participants for their enthusiastic involvement and making this FDP a grand success. Without you, the FTP was having no sense at all. Your continuous means engagement in the session was a true inspiration for all the speakers throughout the session. So thanks a lot. Thank you so much, all the participants, for your active involvement in the uh, series of lectures in the FTP on deep learning, sponsored by ENICT Academy, MNIT Jaipur. Thank you. Thank you so much. Thank you so much, Surendra sir. Thank you so much, Ashutosh. And thank you, whole ENICT support team.
so any participant, please, if you want to give any feedback, any suggestions, so I request Ashutosh, please can you unmute So all the participants, if someone want to say, then they can.
Surendra sir, we may share a Google form asking for their valuable feedback so that we can keep them as a document for us.
Yes, sir. Actually, there is a network issue, so maybe at my side. Ashutosh, can we unmute all the participants if possible?
Yes, sir, I
Hello,
have done that.
friends. I request if you want to say something or if you want to give any feedback regarding this FTP.
Am I audible, sir? Surendra sir?
Yes, yes, sir. Yes, sir. So,
Actually, I just suggest to have some Google form. We will circulate one Google form. There we expect some genuine feedback for our FTP so that it can it will be valuable for us and it will be with us through some documents. So I request Astos to just share one Google form to all the participants who have joined the FTP. Isn't it fine, sir, if you share the Google form?
yes, sir. So we will share the Google form to all the participants so they can write in the Google form any suggestion or feedback about this FDP. Okay, so shall we wind up this session or this course FDP, sir?
Just a minute, sir. Just a minute.
Okay, sir.
So, actually, I would just like to uh, just provide one information that we are again conducting one FDP on malware analysis that is related to cyber security in August 25th. It is going to be started. If someone is interested, I request you to kindly register there. Uh, I hope we may see you there. So thanks a lot. Thank you, Suren sir. So we may now conclude the session and close for the day.
Yes. So thank you, sir. Thank you, Ashutosh.
Okay, sir.
Yes, you can close the session. Thank you. Thank you, all the participants. Thank you very much.